See, chemical kinetics as such deals with rates or velocities of chemical reaction. It is a branch of physical chemistry which deals with the rates or velocities of the chemical reaction. Based on rate, reactions can be classified into, say, fast reactions, reactions of moderate rate, and then slow reactions, right? Coming to fast reactions, fast reactions are those which are completed in fraction of a second. I mean, they are completed in milliseconds. Okay, let us take them here. Let us take an example. See, a precipitation reaction. In this reaction, when aqueous silver nitrate is treated with aqueous sodium chloride, a precipitate of silver chloride is formed in 10 power minus 4 seconds. Okay. See, because these reactions take place very fast or very quickly, rate of these reactions cannot be determined. Now, of course, the reactions of moderate rate or moderate reaction. See, these are the reactions which take place with a measurable rate. Most of the lab reactions come under this category. Okay. In case of which it is of course possible to measure the rate or velocity. Next. Coming to the third variety, that is slow reaction. See, these are the reactions which take months to complete. We can take rusting of iron. Okay, it of course takes months to complete. So, because these occur very slowly, the rates of these reactions cannot be determined. Okay, let us now discuss in detail about the rate of reaction. It can be simply given as change in concentration by time taken. Okay. It can be broadly given as the change in or decrease in the concentration of reactants with time or increase in the concentration of products with time at any particular time. We have to mention time because rate changes every instant. Okay. Even this rate can be given in two ways. Let us take them now. Now consider a reaction. Say A gives rise to B. Let us first take with respect to reactant. And in this, let us first consider the average rate. Okay. Let me explain this taking a graph. See, at the beginning of the reaction, concentration of A will be maximum. But as the reaction goes on, concentration goes on decreasing. Okay. Now, let us take 2 points into consideration. Let this be A1 at a T1 and this be A2 at a T2. Now, if you consider average rate, see it can be given as delta A by delta T. As the concentration of A decreases with the time, it can be shown as minus a delta A by delta T. Yes, let me show it. What do you mean by delta A by delta T? Delta A can be given as A2 minus A1 by delta T can be given as T2 minus T1. But because A2 is less and A1 is more, this value comes out to be negative. To make it a positive value, a minus sign is in fact used. Of course, it can be given in 2 ways. Minus refers to decrease in the concentration of A with time. And of course, the overall value can be made positive, taking this negative sign. Okay. Now this is average rate. Here this delta refers to finite change, measurable change in the concentration of A, finite change in the concentration of A in finite interval of time, delta T, right? Now this is average rate. Going for the second one, see, it is called instantaneous rate. Okay. As I said, rate changes every instant. So it is in fact given per instant. Look at this. Concentration versus time again. Concentration of the reactant goes on decreasing. To know the instantaneous rate, we have to take the slope of tangent. Okay, slope of the tangent. Okay. Now this can be given as mathematically it can be given as d concentration of A by dt, where this d refers to small change in the concentration of A in small interval of time dt. I think you know that the slope of tangent is like y2 minus y1 by x2 minus x1, right? Okay. Even here also, let me put a negative sign. Now this can be given as minus d, nothing but small change in concentration of A in small interval of time. And here also this minus sign refers to decrease in concentration with the time. So this is the second variety. Okay. Now this is with respect to reactant. It can also be given with respect to product. B. See, the concentration of B in fact goes on increasing with the time. Let this be B1 at a T1. This be B2 at a T2. Now, the average rate you can say or AB can be given as delta B by delta T. Anyway, B2 is greater than B1. So final minus initial, we are going to get a positive value. But still it has to be written here. Remember, it has to be positive. In fact, indicates increase in concentration of B with a time. Finite increase, delta, finite increase in concentration of B with a time. So the same can be given as plus B2 minus T1 by T2 minus T1. That's it. That is the average rate. Now the instantaneous rate with respect to the product. Again the same, taking the slope of the tangent. Okay. So this can be given as dB by dt, where d refers to small change in the concentration of B in small interval of time dt, and of course plus, even that has to be written. Plus should always be written, it should not be ignored. Okay, so this is all about the average rate and instantaneous rate with respect to the reactant and the product. Now, some more details. Consider a reaction A plus 2B gives rise to C plus 2D. Be little careful. This is going to be much more interesting. Now, if we consider the rate at which D appears or D forms, look at this. The rate of appearance of D can be given as 2 times of the rate of disappearance of A, right? Because when 1 mole of A is disappearing, you are getting 2 moles of D. So rate of appearance of D can be given as 2 times the rate of disappearance of A. Okay. Can also be given as equal to the rate of disappearance of B, right? Now finally, taking these two into consideration, rate of appearance of D is 2 times the rate of appearance of C. Is that right? Here in case of C, we are taking appearance. Check this out. Now let us write the same mathematically. Okay. Now, we've actually taken D into consideration. With respect to this, rate of appearance of D can be written as plus D concentration of D by dt, taking the instantaneous rate into consideration. Okay. Now this can be given as see with respect to C, it is see the rate of appearance of D is 2 times the rate of appearance of C, isn't it? Say this is the rate of appearance of D. It is equal to 2 times the rate of appearance of C, isn't it? Next. Coming to B. It can be given as equal to the rate of disappearance of B. Just a second. It has to be minus. Right? Say this is the rate of disappearance of B. Rate of disappearance of B and the rate of appearance of D both are equal. Finally, with respect to A, see with respect to A, rate of appearance of D can be given as 2 times the rate of disappearance of A. You can check this carefully. Come on, once again. Rate of appearance of D, this one is 2 times of what? The rate of disappearance of A. Fine. Next. Rate of appearance of D is equal to the rate of disappearance of B. Fine. Rate of appearance of D is 2 times of the rate of appearance of C. Now the same can of course be written as, look at this, minus D concentration of A by dt is equal to, dividing by 2, half of minus a dB by dt, nothing but plus a dC by dt, nothing but plus, no problem, half of or plus half you can write. Okay. Plus dd by dt. Look at the, just dividing by 2. Now look at the issue. The number of moles has come into the denominator. That's it. Even now you can see the same thing. Even now we can explain the same. Look at the same thing again. Say this is the rate of appearance of D. Now when this 2 goes here, it becomes 2 times the rate of disappearance of A. That's how you have to understand the thing. Is that okay? That means the number of moles comes into the denominator or becomes a reciprocal. So in general, for a reaction, PP plus QQ gives rise to RR plus SS, rate of reaction. In terms of capital P, capital Q, capital R, and capital S can be given as, come on, minus 1 by small p, the number of moles, dP by dt, that is equal to minus 1 by q, d capital Q by dt, taking the number of moles as the reciprocal, 1 by R d capital R by dt plus 1 by S small s d capital S by dt. That's it. So this is how rate of reaction in terms of the reactants can be given. Okay.